So ito yung continuation natin sa naputol natin na or pinutol natin na usapin. Patungo na tayo sa tritium at saka yung part pa rin ng deuterium. So, meron tayong babasahin na article. This is from Science article, June 2022. So, from Canada ito, no? So, anyway, napag-usapan nila. Okay, so ito. In 2020, Canadian nuclear laboratories delivered 5 steel drums lined with cork to absorb shocks to the joint European torus. That's the jet. Yan yung kanilang fusion reactor sa Europe. Sa United Kingdom ito. Inside the drum was a steel cylinder. Ang size ay parang Coke can lang ito, holding a wisp of hydrogen gas. About 10 grams of it, or the weight of a couple sheets of paper. So, napakaliit, ano? So, this wasn't ordinary hydrogen, but it's rare radioactive isotope tritium, in which 2 neutrons and a proton cling together in the nucleus. Ang price pala ng tritium at $30,000 per gram. It's almost as precious as a diamond. But for fusion researchers, the price is worth paying. Kasi yung tritium combined at high temperature with its sibling deuterium. This is sibling deuterium. The two gases burn like the sun. The reaction could provide abundant energy just as soon as fusion scientists figure out how to efficiently spark it. Just as soon. So ito yung this is before nila na-achieve yung dahil katulad nung in-explain ko kanina, positive and positive nagre-repel yan, no? Pero merong threshold yan. Pag pinipilit nila mag-abot yan hanggat malampasan yung threshold, mag-fuse yan. So yun yung nangyari. So this is delayed itong nila, hindi nila ito na-update pa, but they are talking about the potential issue kung magkatuloy man, magkakaroon ng issue ng tritium supply. So, sabi dito, last year, the Canadian tritium fueled an experiment at JET showing fusion research is approaching an important threshold, producing more energy than goes into the reactions. So, yun yung sinabi nila kanina, na-achieve na nila yung explanation natin na 1 litro, 2 litro ang labas. So, ganon. No? By getting to 1/3 of this break-even point, JET offered reassurance that ITER, a similar reactor twice the size of JET, under construction in France. So, UK has the JET, France has the ITER. Ito yung mga reactors, JET under construction in France, the size of JET under construction in France will bust past break-even when it begins deuterium and tritium burns sometime in the next decade. So medyo delayed sila, behind sila. What we found matches predictions. So, sabi rito, but the achievement could be a Pyrrhic victory fusion scientists are realizing. So, medyo kinabahan sila dahil pag nag-succeed tayo, wala naman tayong fuel. Paano yun? So parang nabagok yung excitement doon. ITER is expected to consume most of the world's tritium, leaving little reactors that come after. So, ito na yung sinasabi ko, magkakaroon ng competition, everybody's gonna need this, tataas yung presyo nun. So dito sabi nila, fusion advocates often boast that the fuel for their reactors will be cheap and plentiful. That is certainly true for deuterium. Dahil sabi nga nila, it's plentiful, it's abundant. All the seas have that. Roughly 1 in every 5,000 hydrogen atoms in the oceans is deuterium, and it sells for about $13 per gram. Okay? So yun yung current price nito, It's from Science article. They know the price because they deal with this business every day. But tritium, with half a life of 12.3 years, exists naturally only in trace amounts in the upper atmosphere, which is, sabi nila, sa moon abundant ito. Today, that's why they want to go back to the moon. The product of cosmic ray bombardment. Nuclear reactors also produce tiny amounts, but few harvest it. So yung fusion, yung fission, yung nuclear reactor, like bata nuclear power plant, example lang natin yan, which is even if it's not working, if it starts working, it would produce a little bit of tritium, which is probably not a commercial quantity, but understandably a good reason to know. Most fusion scientists shrug off the problem, arguing that future reactors can breed the tritium they need. Future reactors can breed the tritium they need. Tandaan nyo yan, ha? Meron tayong titingnan dyan na possibility. The high energy neutrons released in fusion reactions can split lithium into helium and tritium if the reactor wall is lined with the metal. Despite demand for it in electric car batteries, lithium is relatively plentiful. Yes, may maraming lithium na supply. So, pag nag-agawa na yan na kukulin yung supply ng lithium, di pa-prioritize yan. Yung mga electric cars ngayon, problema ngayon nila ng supply ng lithium sa battery. Kaya that's why I'm not a big fan of electric car. Binanggit ko na yan because for this reason, I know that someday there will be shortage of lithium. Besides the fact na yung mga battery pag nag-expire na yon at hindi na nag-generate ng panibagong energy, you have to dump it. Napakarami niya, no? So, just as much as what we see now sa mga telepono. Pagka nagkaedad na yung cellphone natin na 3 years old, 4 years old, 5 years old, yung battery, hindi na nagcha-charge ng fully. So, we have to replace it. Di ba? So, okay lang kung may mabibili kang extra battery na energizer. Ang kaso, hindi ganyan kadali. Hindi available sa mga tinda-tindahan yung mga lithium. No? So, and there's a lot of it, man. So, but there's a catch. In order to breed tritium, you need a working fusion reactor. And there may not be enough tritium to jumpstart the first generation of power plants. The world's only commercial sources are the 19. The world's only commercial sources are the 19 Canada deuterium, uranium, which is CANDU nuclear reactors, which each produce about 0.5 kilograms a year as a waste product, and half are due to retire this decade. The available tritium stockpile, thought to be about 25 kilograms today, will peak before the end of the decade and begin a steady decline as it is sold off and decays, according to projections in ITER's 2018 research plan. So, sabi nila, firik yung achievement, dahil damn, wala pala tayo. Kukulangin pala tayo ng gasolina nito. Nakaka-invento tayo ng bagong sasakyan na mapapatakbo natin ng malayo. Pero anong gasolina natin kung kulang, no? So, yun yung challenge. So, we see the challenge, okay? Now, halimbawang, okay, ang source ng tritium is kulang. So, kukuha sila sa moon. Malaking gastos yun. But, one thing that we have to understand, deuterium can become helium. How? Tanong dito, how does deuterium become helium? Types of fusion reactions. Sabi dito, two pairs of protons, hydrogen atoms, collide and become two atoms of deuterium. Each deuterium then combines again with a proton, hydrogen, to form helium-3, which combine again and eventually form the helium-4.
What we saw is that there's some better fusion reactions, and deuterium and a rare isotope of helium called helium-3, and you fuse those together and you make helium-4 and a tremendous amount of electricity.
So, guys, look at that. Yung deuterium itself can actually produce the helium. So they can forget about tritium. Kung mahirap hanapin ng tritium at nagkakaubusan na, then let's go dig from the deuterium. So ngayon, paano, alam na natin ngayon na, you know, this is not a joke. This deuterium is not a joke. Okay? So, balikan natin yung challenge na binabanggit nila, no? Karoon ng shortage ng tritium. Na perfect mo na yung fusion. Halimbawa, merong available yung deuterium, pero yung tritium is there's gonna be a shortage. Now, dito papasok ulit yung role ng deuterium, no? So, let's say for instance na explore natin yung deuterium sa Pilipinas and we eventually found that we can source it out into a commercial grade para mabenta natin. So, it's like extracting some natural gas, although this will be more complicated than that. But then, there is a big demand. So, kahit pa sabihin nila, oh, okay, you're not the only one that's having a lot of deuterium, but, you know, there's abundant all over the place. But question is, can those people supply the demand? No? Katulad ng natural gas. Natural gas are all over the world. But then there's countries that has like abundance of supply, like Russia, United States, Iran, Qatar, you know, and China. They have that. But not everyone. Like Germany needs natural gas. They're buying from Russia. Now, na natigil yung dahil binombahan yung Nord Stream pipeline, bibili sila sa United States. So, you know, there is abundance to it, but there's a country that's gonna need it. Especially now na yung nuclear fusion is gonna scale up the production kasi palapit na discover na nila kung paano nila i-reproduce yung energy with less than the input. So, they're gonna crank this up even more. So, kakailanganin, it's about time. So, now, kung hindi makahanap ng tritium to create the helium, well, deuterium is available. Now, let's find out what else deuterium can do. Let's watch this.
The heat we feel from the sun is emitted from its surface, which is over 6,000 degrees Celsius. That's nowhere near hot enough for fusion to take place, though. So let's move deep down into the core of the sun, where the temperature and pressure are high enough for fusion reactions to take place. At the sun's core is a dense hydrogen plasma, a soup of electrons and protons. The protons are shown here in red, and it's these particles that we'll focus on. They bounce around with tremendous force, but they don't want to collide with each other. Positive charges repel, so when two protons get close, the repulsion makes them swerve apart. The closer they come together, the stronger the repulsion gets. These protons really don't want to be close to each other. Every so often though, two protons will hit each other in a head-on collision, which will force them very close together, and a new force will come into play. It's called the strong nuclear force. It only works over short distances, but get two protons close enough together, and this force can overcome the repulsion caused by their positive charges. The protons are pulled tightly together, at which point something a bit
ayan na yung fusion, Nakita natin, napanood natin, explain na nagre-repel sila. Tapos, eventually, pag napalapit sila, dahil, you know, they bounce around, nagbabounce sila, hanggang sa mapalapit, at yung strong force enough would break the threshold, and they will fuse. Ito na yung in-explain natin, very clearly.
Weird happens. One of these protons emits two smaller particles. One is a neutrino, a tiny particle that moves at almost the speed of light. These ghostly particles can scream through matter as if it's not there, so although this neutrino gets emitted deep in the core of the sun, it just streams out into space, never to be seen again. The proton also emits an anti-electron. This is the antimatter version of an electron, and whilst a normal electron has a negative charge, this has a positive charge. Remember this anti-electron, we'll come back to it later. This particle carries the positive charge away, and so the proton, having lost its electrical charge, becomes a neutron. It's a process called beta plus decay, and this is how the neutrons in helium get formed. We're now left with a proton and a neutron joined together. A heavy form of hydrogen called deuterium. This deuterium nucleus will bounce around in the sun's core with all the other particles, but will very quickly have another encounter. Within around 1 second, it will have a head-on collision with another proton, and they'll come together with enough force for the next fusion event to take place. The strong nuclear force will once again work its magic, and the proton and the deuterium will snap tightly together to form a new nucleus containing 2 protons and 1 neutron. This is a light form of helium called helium-3. When this fusion takes place, it emits a powerful gamma ray which gets absorbed by the surrounding plasma and adds heat to the sun's core. The helium-3 nucleus that was produced bounces around in the dense solar plasma with the other particles until eventually it meets another helium-3 nucleus. If they meet with enough force, the final fusion event takes place. Once the nuclei are close enough, the strong nuclear force takes over and pulls them together forcefully. We now have 6 particles pulled together, but this final fusion event ejects 2 of the protons from the newly formed nucleus. Being fired back into the plasma with huge force, they add yet more heat into the sun's core and will get reused in further fusion events. The nucleus that remains consists of 2 protons and 2 neutrons, known as helium-4. This helium is the final end result of the fusion reactions that have taken place, the sun's exhaust gas, if you like. But there's a loose end we still need to tie up, the electrons. The fusion reaction shown here fused 4 hydrogen nuclei into 1 nucleus of helium. Each of these hydrogen nuclei had an associated electron, so 4 electrons in total. A helium atom, though, only has 2 electrons, so we have 2 electrons left over. Ones that used to belong to hydrogen atoms, but have no place in the new helium atom. What happens to these leftover electrons? Remember those anti-electrons from the first stage of fusion? They will quickly collide with the leftover normal electrons, and when a particle and an antiparticle meet, they emit a flash of gamma radiation, and then they're gone. The particles are annihilated, leaving nothing behind. And the gamma ray flash that was produced when they met adds even more heat into the core of the sun. And so those leftover electrons have vanished, and we've balanced the books. This is how the sun fuses 4 hydrogen atoms into 1 atom of helium, and it does this 100 billion times per second, and has been doing so for the last 5 billion years. The heat produced by this fusion process works its way to the surface of the sun and, after an 8-minute journey through space, provides the Earth with its daylight and its warmth.
Wow, so that's deep physics. So nakita natin yung paano ang nature nagtatrabaho to provide the heat at saka yung light na, you know, when the sun is out, we have a good daylight, we have good heat, we provide energy to the solar who absorbs the energy, you know? So yun yung possibility, and all these things they are now doing in the laboratory at saka dun sa nuclear fusion. So itong issue ng shortage ng tritium can actually be resolved by working on the abundant deuterium. So let's think about it. No, hopefully, you know, sa Pilipinas, enough people would understand, tsaka yung mga official natin, and they would start thinking, yeah, why don't we start putting some study on this kasi hindi talaga nila ito inano dahil yung mga critics binabara takot, natatakot sila. At saka of course the funding is very expensive. That's why meron tayong nilagay na video We have to be careful who should we ally with. Alamin natin kung sino yung mapagkakatiwalaan natin because eventually we're gonna need investors in here. Hindi natin kayang i-fund ito ng tayo-tayo lang. So we need outside investors. We have to protect our interests dahil may mga investors that they will make it sound like, we're supporting you, we're here for you, but eventually they have their own special interest, vested interest. Marami yan. At alam natin yan. So, yun ang point doon. But the thing that we understood here from the time that we started this study until now, alam natin na deuterium is going to be in high demand. Not in the distant future. Kasi kahit na hindi pa nila ma-perfect yung pag-provide ng energy, the research study that they've been doing in the past 60 years, na perfect na nila yung pag-reproduce. I mean the physics of putting together. Hindi pa nila na perfect yung pag-produce ng energy. But it only takes a little more time. Tapos kailangan nila ng additional more, to test it. So, ngayon, commercially, nabibili na yung deuterium in the market for $13 per gram. Why don't we start making our own and jump in and start selling 13 grams, but $13 per gram? Of course, we have to understand kung what's the cost involved in producing the gram. Kung ang cost naman is $12.95 bago makabuo ng isang gramo, then, it's not worth it. But then, we're never gonna know until hindi natin ginawa, hindi natin napag-aralan. What if maraming mga talented na Pilipino, no? Besides mga talentado, merong mga talento ng mga Pilipino. I really believe, I'm not joking here, no? Ang mga Pilipino, when you put them on a challenging situation, man, they will innovate. We are innovators. So, hindi natin malalaman kung sino sa available na talent ngayon that can discover of extracting deuterium and producing it and producing a quality grade, commercial grade in large quantity in less amount of money. Unless we put that out and support it, hindi natin malalaman. That's why deuterium study is very important. As much as we wanted the Bataan nuclear power plant to start rolling, the government should start putting together heads, looking for funding kung paano simulan itong deuterium study. I'm sure there are groups already that are doing it within the government. But open it to many other groups that would have an interest to it and perhaps a good expertise to not only initiate but expedite the process dahil ang karera is moving very quickly. Let me close this with this highlight.
A team at Lawrence Livermore National Lab, National Ignition Facility made the following happen. There's a tiny cylinder here at the end of this that you probably can't see. It's about so tall and this wide. Inside that was a small spherical capsule about half the diameter of a BB. 192 laser beams entered from the two ends of the cylinder and struck the inner wall. They didn't strike the capsule, they struck the inner wall of this cylinder and deposited energy, and that happened in less time than it takes light to move 10 feet. So it's kind of fast. X-rays from the wall impinged on the spherical capsule. fusion fuel in the capsule got squeezed. Fusion reactions started. This had all happened before, 100 times before. But last week, for the first time, they designed this experiment so that the fusion fuel stayed hot enough, dense enough, and round enough for long enough that it ignited, and it produced more energies than the lasers had deposited. About 2 megajoules in, about 3 megajoules out, a gain of 1.5. The energy production took less time than it takes light to travel 1 inch. Kind of fast. So this is pretty cool. I have a special message to listeners who want to work on exciting, challenging, and important problems. We're hiring.
So that's exactly what our government needs to do right now. Okay? Understand this trend, understand what is happening, and the demand. And let's jump into the race. Hindi man tayo handa sa nuclear fusion reaction race or reactor race, we can somehow play a role in providing the fuel. So, hopefully, there's enough of us that are talking about this and sharing it and subscribing and putting it out. I don't care. Copy the video, share it all over the place, talk about Deuterium everywhere, talk about the trends. This has got to come out. And some thinking heads up there na binoto natin in the government would start, not only dabbling, but really, really activate the Filipino ingenuity, the Filipino talent, support it with funding because we have the resource. I don't care kung sabihin ng iba na, there's deuterium in all places. Who the hell cares? We know we have deuterium. We have to extract our deuterium and figure out if we can get into a competitive grade and quantity, because there is a demand. There is no freaking doubt about it. There is a demand. Pilipinas, ito na yung mga pinag-uusapan noon na pinagtatawanan nila na, suntok buwan. Yung deuterium na yan, ano lang yan, parang kwentong barbero. But now, we see the realization. Every nuclear fusion reactor that is working right now to come up with the cool energy that's green is talking about deuterium. It's not a joke. Kung $13 per gram ngayon, imagine what it's gonna be like when there's 3, 4, 5, 6 nuclear fusion reactor that are working to produce electricity. Dahil yung electricity ipoproduce nila, they will sell it to countries who cannot run a nuclear fusion reactor. But they need the fuel. Deuterium is one of the fuel. Not only one, it's potentially the one that would recreate the final fuel that would produce the energy, which is the helium-4. Okay, so hopefully na-enjoy niyo yung video, and usapin lang ho natin ito. We back our research with data and the trends. Hindi ho ito kwento na nangyari 50 years ago. These are 4 days ago, 5 days ago, 8 days ago. So, and it's still happening right now. So, maraming salamat mga kababayan, and hopefully we'll continue to have our discussion, at marami ho tayong very exciting topic na pag-uusapan, and our topic is going to be beneficial ho sa lahat. Hindi lang ho ito nakikisaw-saw tayo na wala ho tayong mapapala dahil eventually each of us would understand how to position ourselves and get ready. Especially yung mga taong nandyan sa Surigao, na malapit sa Surigao Deep. You better understand your situation there, you know. Ako, at least I know how to position myself when I go there. I'm actually having talks right now with people that I can, do venture with. Kasi you don't jump into the game when everybody's already running. You jump into the game when they are still talking about it. You prepare yourself. Ganyan ho ang dapat na isipin natin. Keep that positive mindset that merong malaking pag-asa ang Pilipinas na makaahon sa hirap. And forget about the corruption and the politics. Let's be proactive as a citizen, you know? Katulad nung binanggit ko, I quote from JFK. Ask not what your country do to you or for you, but ask what you can do for your country. Yun ang purpose ng ating talakayan. We try to educate each other. We try to be informed. We try to understand what's going on para alam natin kung saan tayo lalagay. You'll never know, isa sa atin may makontribute na matinding impormasyon or iilan sa atin ang makabenefit dahil naintindihan natin and we understand kung saan tayo lalagay in terms of career, profession, or business-wise, entrepreneurial skill. But always think about this. We are born survivalists and natural ones dahil sa hirap ng dinaanan natin. Filipinos are innovative. Basta tanggalin lang yung crab-like mentality at poor mindset at syaga negatibong pag-iisip. Expand your imagination. Think about the possibilities. Okay? So, mga kababayan, see you again next time. Have a wonderful, Merry Christmas and stay safe always.